Hello, welcome to day 4. So today we're going to be working on writing equations of translated lines. So you're either going to be given an image or an equation, like a written out equation, or a description, and you're going to be writing down that equation. It's kind of the opposite of what we've been doing. So now our warm up again is just matching these. So our f of x equals x, so that linear, remember linear is that straight line. So linear, think line, linear, straight line right here. Now quadratic, remember quadratic, is that when if y equals x squared, is that U shape. So there's a U shape like the parabola when it's squared, so it's a U. And cubic, remember, so I think that John Travolta, Saturday Night Fever, or is it Friday Night Fever? Either way, it's from the 70s. So John Travolta, cubic, down here. So it's making that weird arm kind of disco dance kind of shape. And square root, remember, because we cannot have a square root of a negative, so we're not going to have it be on the negative side of the y-axis. So there's nothing on the negative side of the y-axis here. So that's that pairing. Remember absolute value. So that v, think it's v-shape, absolute value. It's going to be this one up here. And last but not least, we have our rational equation, which is here. Okay, this was just probably more review for you guys. But again, I just want to solidify this in your mind. You're going to want to know what these different shapes of these different parent functions look like, because you will have to identify some. Hint, hint, it will be on your quiz, so make sure you know what these look like. Okay, so now we're going to be writing an equation given a parent function and the translation. So we're given the type of function it is. So for this number 1, we're given it's a quadratic, so it's x squared. And we're going to be writing down an equation, so it translates it to or left 2 units and down 1. And we can go down to here. So left, that's the horizontal. Left or right is the horizontal shift. And the down, up or down, is that vertical shift. So if we're trying to write down our horizontal shift, which is that green underlining green, so remember we can go down here, know that it's within it. So I'm just going to write down that we know it's going to be, since it's left, we know it's being added because it's left units. So we'll say plus 2. Remember our original function was x, and since it's within, see here, it's within the grouping, it's going to put it within that grouping there. And then down 1. So since we're down, it's subtracting 1. This will be a little bit of review from the day before, but this is just translating, taking it from the description and putting it into the equation, kind of like doing the flip-flop of what we did the other day. Now we have an absolute value here. So we have x, just going to leave that some space here. Let's figure out our horizontal shift. So it's going right 3. Think right, so since it's going right, it's subtraction. So minus 3, and then up 4, since that's the vertical shift. And since it's up, we know it's positive, so plus 4. And now the last one here, we have our rational equation. So I'm just going to do 1 over x down here, leave some space. Now our horizontal shift here, it says it's going right 1 unit. Remember, right is subtraction, so minus 1. And then we're going 5 units down, so that's minus 1. And that is not, make sure this is not on the denominator. It's kind of separate from, it's separated from the whole fraction itself. So essentially it's the same thing as saying minus 1 over 1. Or you can just say minus 1. Remember, it's very key on today that you don't mix up your horizontal and your vertical shifts, because if these were to be switched places, that would be a completely different function. So make sure you're putting your horizontal shift within that grouping. So within, so for instance, if it's absolute value, make sure it's within the absolute value signs, or if it's within the parentheses. But if it's a vertical shift, then it's outside of it. It's kind of like attached at the very end or beginning. So it's not having that parent function be part, it's not part of that parent function. See how it's in that -3 for the horizontal shift is within the absolute value sign? That's because it's within that parent function, if that makes any sense. Now we're given the graph, we're going to write the function, and we're going to do it in like different steps. So first let's write out the parent function. Well, it has that like kind of like that disco-y kind of shape to it. I like to call it the disco shape. So that's x cubed, so that's cubic. I'm just going to write x cubed. You don't have to rewrite that as cubic, but one or the other works. Critical value. This is probably new to you guys. I'll let you know the critical value of every single one of the parent function's original shape. Like for instance, back here, where it just says equals x squared. So if it doesn't have any other numbers attached to it, like a +1 or whatnot, if it's just that by itself, its critical value is always at the origin. So think the original critical value is always 0, 0. I'm going to say equals original. But with that being said, we're going to be looking at the point where the kind of, I like to say the center of the shape of the graph is, in a sense. So, because remember how it would be like this otherwise, and it would be here. That's what I mean by that origin, is that original critical value. The new one, if I erase this here, the new one is actually here. You see where that center, where it starts to kind of change, where it starts to change direction. That's that critical value, where it's that center where it starts to shift. And now, since we know what the new critical value is now, ordered pair -1, -2, we can take that critical value and help put that into our translation. So we know that our old one, our original, would be at the origin here. So think of, we're going left 1 unit, so left 1, and we're going down 2. Down 2. So now that we know the translation, now we can put that back into our equation. So we know our parent function, and we know our translation. The critical value was to just help you find your translation. So we have x something cubed, and then we're down in plus or minus something. Now we can fill this in. Well, we go in left 1, so that means it's +1. We're going down 2 means -2. So that would be the equation of this new graph here. We'll do some more practice with it. So on the next slide here, our parent function, we see it's a straight line, so we know it's just y equals x, or it's that linear line. And our new critical value is where it's kind of, it's for this particular example, it's where it crosses that the y-axis. So it's at that 0, 4, so it's this point right here. This one is kind of tricky because you can rewrite this as multiple different ways, but in particular, when we're doing this example here, we're going to just refer to the y-intercept as to be our critical value, because it doesn't really change direction at all. Because normally that critical value means where the function starts to change direction, or where it has like a different, just when it changes direction. But since it's linear, it doesn't ever change direction. It's going the same line the whole way through. So our translation As remember, our normal one would have crossed through right here. Oh, whoops, that wasn't very accurate. Right here at 0, 0. So it's really, our original ordered pair would be 0, 0, but the new one is 0, 4, so it's just going up 4. So now our new equation is y equals x, since it's up, plus 4. And that would be your equation for this line here. The next one here, we're just doing some practice ones to help you guys get a better understanding. So the parent function, so it's shaped like a V, so it's the absolute value. The critical value, remember, see our critical value, it used to be 0, 0. So it was like this before, but for it to, now it's right here, where that changes direction. So it changes, see how it has a negative slope, but then it changes to a positive slope? That point is that changing direction, or where that center of the graph is. So our new critical value, we have, 2, 0. Our translation, it didn't, let's see, if we're starting here and we go this way, we're going right 2 units. We're not changing in a vertical distance. We didn't go up or down any. So our new equation, we have f of x equals x, in sense it's going to be plus or minus something. Well, plus or minus 2, because that's that value here. But if it's plus or minus is the question, because if you look back to this, since it's, wait, what was it again? Yeah. So since we're going right 2 units, think right, so it's subtracting. So then we're picking the subtraction sign. So it's absolute value of x minus 2 would be that new equation. And I think you guys have gotten the gist kind of in a sense. So always, it's going to be beneficial to refer back to this graph or little chart here. And remember to not mix up your horizontal and vertical shift, because that will get you a completely different answer. But remember to complete the attendance form, the homework assignment, and the homework quiz. And as always, feel free to email if you have any questions.